There's a ton of debate about these shoes here and if they provide extra benefit that is actually cheating. And we're going to go over, why that might be true, why that might not be true, but ultimately, why you don't need the fancy shoes. You just need the speed equation. That doesn't mean you don't need spikes or that you don't need new spikes every season. You do. It's a part of your gear, right? It's one of the beautiful things about running is that all you need are proper shoes, and even then, you can run bare feet. But if you want to run fast and you want to be competitive, you need spikes. So the physics of running fast. That's me running kind of fast, I suppose. Um, F equals ma, force equals mass times acceleration. So this is me, Coach Chase. I worked in biotech for 6 years. That's me. Uh, Pretty cool picture. I studied kind of hard, not gonna lie. Um, I did well though, so that's a plus. Physics was always tough for me, but I think my background in studying for it will help me explain some of the basic physics concepts to you today. And I'm hoping to translate my lab experience, including the science, including the research, into real world speed gains. But here's the question I couldn't answer in the lab. How can I translate basic physics into running faster? The myths of speed. Got our little animated guy here running for his life. Form isn't horrible overall. Needs to stand up a bit. Look at that big head. The big head is making him lean forward a bit. Everyone thinks speed is like turnover or quickness, as we mentioned before, or the newest Nike spikes, or I'm too short, or I'm too tall, or I am slow. The truth is that running fast is just based on physics for the most part. We went over force equals mass times acceleration, right? This is Newton's second law. Mass is kilos. Acceleration is meters per second or meters per second squared. Force is the force on the object measured in newtons. Example, if in the first 2 seconds of the race, a 94 kilogram athlete accelerates, that would be 190 pounds, 180, so 90. Is that 200 pounds? No. Yeah, 190 pounds, whatever. Accelerates at a rate of 5 meters per second squared. Calculate the force that is required to achieve acceleration. So this is even something that you could do if you take your average 100-meter time. You can measure your average acceleration. So it's your mass, which is basically 94 kilograms times 5 meters per second squared, 470. Now, don't worry about that. We're not going to be doing math today, and we're not going to be doing difficult physics today, but I found this little meme to help lighten up all that math that we just did, right? It's a play on F equals ma, because when your force is divided by your mass, you get acceleration, right? So you could change different factors in your equation, whether that's the force that you produce by getting stronger, or whether that's your acceleration, or you can change your mass. Like you can lose weight, or in this case, you can go to space. The secret to speed isn't how fast your legs spin, it's physics. My athletes call me Unk, which is hilarious because that was a Unk joke right there. That's funny. Okay. So the speed equation, this is what I'm saying, right? Speed is basically stride length times stride frequency times this mystery factor that we're going to go over. But first, we're going to discuss stride length. So your legs are levers. If you don't know what a lever is, I'm about to show you. The harder you push the ground, the farther you fly forward. So you have this lever here, right? You have this fulcrum point where this triangle is. That's where all the weight will be distributed. And you have this rock that you want to move, right? So the longer this lever, the easier it is to move. The shorter this lever, the harder it is to move. Imagine like the triangle's down here and you have a toothpick, and even if it's a metal toothpick, right? trying to move this rock is much more difficult than if you have this big pole, which is more difficult than if you had a pole that was like way bigger than this. Another example is doors. Doors actually used to be made with the doorknob in the center. You see this doorknob? But it's much harder to open this door than it is to open a regular door. If you see this fuzzy picture of a door, the doorknob's way over here, right? So measure this doorknob to the end, right? The pivot point is here. So opening this door, this distance is shorter than if you open this door with this distance to the pivot point. I hope that made more sense than it confused people. But essentially, longer lever, you can apply more force. Your legs are lever. Your legs are levers. But longer doesn't equal better. Longer just equals more force capacity. You can theoretically apply more force with a longer lever. So again, the legs are levers. You have your fulcrum point again at the ball of the foot. So this is where your spikes will be located. It helps create another factor that we're not going to discuss today, but traction, which will help you push the earth away, that we will discuss. But this is your fulcrum point. And then all of this is supporting your weight, is supporting the body load. And then this is also this is one lever here, right? Long lever that goes ultimately up to your glute, right around your center of mass, which would be your waist. So your legs are levers. We're going to discuss how to turn them into better levers. So you want to push the ground. You don't want to reach. So the way that you achieve this here is bounding drills. We have one of my former athletes here, Liam, doing bounds in the dark. We're going to rate this track really fast. Looks like we got some maybe maroon or red end zone. Nice little turf. Is this real grass? Oh, this is real grass. Oh, you know, when we do these ratings, if you have real grass, you get plus 1,000 points, right? Got the nice backlit here. This picture, you get the motion graphics. That's a 10 out of 10 picture. You could also do hill sprints and sled pulls to reinforce this concept of pushing the ground as opposed to reaching for the ground. You want to build stride length naturally, right? Some of the drills, again, are bounding, hill sprints, and strides. Strides at 80%. It's probably one of the most useful drills that you could be doing in the preseason, off season. You want to go slow, build this natural length, understand what it feels like to reach, understand what it feels like to be small, and then it's kind of like this Goldilocks method where you find the right balance. But it's really hard to do that when you're always racing or always trying to run really fast. It's much easier when you slowly work up from 70% to 75% to 80%, and you only progress your effort when you are in rhythm and when you're in sync with your stride length and your stride turnover. So that was stride length. Now we're going to discuss stride frequency. So centripetal force is basically your turnover. So how fast you recover your leg through your cycle, determines how many steps, how fast your steps are. When you have faster steps, you can theoretically apply more force, not over a span of time. And we are fighting time here. So this is the equation that we're not going to worry about. The only thing we have to worry about is this R, which is a radius of how fast you cycle. Recover faster to run faster. The faster you complete a full stride cycle, the faster you run. And this is the concept that I was discussing earlier, which is a really important piece of this is full stride cycle. A lot of athletes end up getting straight into sprinting without even understanding what their full stride cycle is. And so then that puts you out of rhythm with the equation that we're working with. Because it is true that the faster you complete a full stride cycle, the faster you run. But when you don't perfect full stride cycles with proper posture, you just are really hurting yourself in the end. And probably not even in the end, but probably like you'll actually hurt yourself. That's what I did, to be honest. Okay, the way you train turnover is with some of the more common drills. You're going to have fast feet, ladders, things like that, high knees, butt kickers. However, true turnover drills, I mean, if you're fortunate enough to have a path that leads down to the track that's slightly downhill and it's paved and you can wear spikes, that's great. Safely running downhill. Speed belt or overspeed training. If you want more information about that, you can head on over to our speed lab. The speed equation, we did stride length, stride frequency, and now it's time to go over our mystery mix of the equation, and that is efficiency. What do we mean by efficient? It's a great return on your energy. So when you apply force into the ground, you get maximum amount of force applied back through you so that you can then go forward. In the way that you work this is through posture, relaxation, and rhythm. You want a balanced stride length and stride frequency. And of course, you want to efficiently incorporate your arm swings to it. Right? Your body is one mechanism, one thing. So not using your arms is not an option. Your body has one battery. Your energy drains down when your mechanics break down. So all the effort and all the energy it takes to make faces and to make noise should instead be put into breathing, into posture, and into your form. So good mechanics save energy. They apply power in the correct places at the right time, and they increase force. Bad mechanics waste energy. They leak power. So even though you're generating the same power as a good mechanics, when you apply that power, a lot of it gets leaked and dispersed into the environment, and you lose force. So the key here is relaxation is speed. So touching back on why it's important to begin with 75%, moving up to 80%, is the relaxation is what puts you in the correct rhythm and scale of stride length compared to stride turnover. It also helps your muscles expand and contract as quick as possible. A tight, intense muscle won't expand fully, therefore loses its delta on expansion and contraction. But the way that you train relaxation, a way you can train it is what's called a potato chip test, right? You could put a potato chip in between your hands if you have your hands partially closed, and swing your arms and maybe do a run with it, and you shouldn't break the potato chip. Alternatively, you could just open your hands. If hands are the beginning signal for tightness, right? Tight hand, tight forearm, tight bicep, tricep, all the way up to my face, whole body tightens up. You can do some posture run drills over wickets, as we've discussed in some of our previous videos that will be linked below. And also, again, hands and face. So if I begin, even if my hands are open, but they can be tense and my face gets tense, that will lead to everything else remaining tense, shorter strides, out of rhythm cycles, things like that. So we've got this triangle of speed, right? We have frequency, length, and efficiency. And the way that the pros train this is balanced. Running fast isn't about maxing one thing. It's not about having the fastest frequency. It's not about having the longest length possible, right? Those are two separate goals. It's about balancing those also while maintaining your efficiency. So again, the way that they do this, honestly, is by starting their sprint journeys early, and not just like age-wise early, but like they begin training 10 months before they actually have to run fast, right? And that helps you really build and really adapt and learn and make all of these phases efficient. So you remember the question, how can I translate basic physics into running faster? There's actually an answer to this, right? It's called the ground reaction force, which is the the force to body weight ratio, force you put in the ground divided by your body weight. Elite sprinters have a 4.4, 4.5x. The way you get there is you train all three levers, the stride length, stride frequency, and efficiency, to raise that number to run faster tomorrow. Now, this is a whole bunch of like, who's going to measure all this? Like, let's be real. The better way to train this is that you run more often. So this includes starting earlier, because that means you get to practice more. And you train at 80% max speed for a long time, until you really understand what it means to be relaxed and rhythmic, until you really understand what proper posture can do for you in terms of your efficiency, in terms of your stride and force that you're able to generate. And of course, you can always film yourself and try to see, where are you weak? Is it your stride length? Are you not running your full length of your leg? Are you trying to cycle too fast? Are you inefficient and moving side to side? You're wasting energy in various directions. And you can film yourself and you can share it with me using the link below. So same physics, different settings. Every runner plays the same physics game, but they choose different settings. So longer levers generally equals slower turnover. Faster turnover generally equals shorter levers. So short people, you're going to have faster turnover. Your legs will cycle much faster. And taller people, your legs will cycle slower, but it'll pay off the further the race goes, because you'll be covering more ground. It's going to take your levers longer to get going, but ultimately, once they get going, they'll be pretty much unstoppable. The person who did this best, obviously, is Usain Bolt. He not only had the longest levers out there, but he had the same turnover as the shorter guys. So a longer lever, same turnover, is going to win 10 out of 10 times. And so then we're just going to recap the drills that you should be incorporating to maximize physics to your advantage of sprinting, of running fast. You'll be bounding in hill sprints and sled pulls, some frequency things and rhythm things. Jump rope is actually more rhythmic in my opinion, but it can be used for frequency. It's jump roping is actually, I need to tell my one athlete that, but it's good for building up that ankle stiffness. You have high knees and butt kickers, which are not really frequency things in my personal opinion, but training frequency is something that needs to be taught. And then you want to be efficient. You want to relax sprinter. You want to do a ton of reps at 80% with perfect posture, perfect form. If you have any confusion about what being relaxed looks like, just again watch any of the Olympians. They're going to be relaxed. They have to be. And that's it. Run like a pro. Train with science. This is where you can submit your film if you have any.